Planning for quality requirements in the project is the first step in quality management. The how part mentions 6 approaches. We will cover cost of quality as an approach in detail, since that is the most commonly used approach in the software industry. But we need to spend a little time on quality requirements, which are gleaned from project requirements, which, as we have seen, is one of the primary inputs to the quality planning process. There are 2 broad categories of requirements that we need to deal with as part of managing quality in a project context. The first category directly relates to the customer and comprises requirements related to the product or service that you are providing to the customer, as well as other project-related requirements such as timeliness, responsiveness, etc., which has a significant and direct impact on customer satisfaction. The second category relates to processes that help ensure internal organizational efficiency or effectiveness in meeting those customer needs. What are some of the product-related quality requirements? Where do you get these from? Very often the only explicitly stated product requirements are the functional requirements. You would be familiar with those and how those are taken care of as part of planning and scheduling. There are other requirements referred to as non-functional requirements or product quality characteristics, such as those relating to usability, maintainability of the product, reliability, product availability, performance-related requirements, and so on, that are very critical but often not explicitly defined or stated. You may find reference to some of these in some part of the product scope document, but for many others, you may need to speak to the customer and extract them based on who the users of the system are and how they are likely to use it for the business purpose. Process-related requirements are intended to ensure that processes that produce deliverables for the customer, such as the design process, review process, testing process, etc., are both effective and efficient. Effectiveness relates to whether the defined processes meet their intended purpose. For example, reviews are intended to reduce defects caught by testing, so effective reviews will reduce leakage into the testing phase. On the other hand, efficiency is related to optimum usage of resources to meet the desired intent or purpose. For example, you may spend 3 hours finding 2 critical defects in a review, while someone else or another project may spend double that time in finding the same number of critical defects. So you are more efficient when you spend less resources for the same objective. Hope you get the point. I'm sure you will appreciate that while both are important, focus on efficiency without effectiveness is not desirable. Process improvement requirements are part of an organization's quality policy-related determination. Improving your productivity or defect removal efficiency over time is critical to stay competitive as well as to provide more value to your customer and your organization. Cost of quality is the total cost of all efforts to achieve the required product or service quality. This includes all work to build a product or service that conforms to the requirements, as well as all work resulting from non-conformance to the requirements, which comes in as defects. It is important to differentiate cost of quality from money spent in developing software. Lifecycle costs, including costs relating to design and development of the product or service, are accounted as production costs. On the other hand, cost of quality is money spent in ensuring conformance of product or service to defined requirements and in detecting and correcting failures, which are non-conformances. Cost of quality is used by many organizations as an operational efficiency measure and is used to drive increased profitability. Any reduction in cost of quality directly contributes to the bottom line or profits. Hence, it is highly preferred as a planning technique by many organizations. COQ is usually expressed as a percentage of revenue or sales. Alternately, where we are concerned with purely software development effort, such as in the case of product engineering centers or R&D operations, COQ is expressed as a percentage of total software development cost. In the next slide, we will delve a little deeper into the various components of cost of quality. In this slide, we introduce you to various components of cost of quality. If the cost is relating to preventing non-conformances, it is classified as prevention costs. Alternately, if the costs are related to evaluating the product or service for conformance to requirements, such costs are treated as appraisal costs. Since both prevention and appraisal costs are focused on ensuring conformance, both these components are treated as costs of conformance. On the other hand, you may discover non-conformances during the evaluation process. If such non-conformances are found prior to shipping the product to the customer, they are treated as internal failure costs. However, if non-conformances are found post-shipment by the customer, they are treated as external failure costs. Both internal and external failure costs are treated as costs of non-conformance. As we mentioned before, life cycle costs related to design, development, etc. are not quality costs and are considered as costs of production. Sometimes measurement and test equipment costs, such as test hardware, test tools, etc., used for appraisal, are considered a separate category, while these are included as part of conformance costs by some organizations. Your organization may have their own way of classifying such costs. Hope you are clear on the various components of costs of quality, as well as the difference between COQ and costs of production. We will now look at some specific examples for each of the components of cost of quality. Now that we have seen what the various components of cost of quality are, let us look at some examples for each category. Let us start with prevention costs. These are costs aimed at preventing non-conformances in the first place. Well-defined, effective processes contribute towards this, and so does effective training of your engineers in writing good and defect-free code. I'm sure you can think of many more examples. The second component is appraisal costs. Examples here include costs related to designer code reviews, which are intended to evaluate conformance of the designer code to requirements, and costs incurred in testing the product at various levels, including integration and system testing. All planned testing done is part of appraisal. However, if there are bugs found from testing, effort spent in analysis and bug fixing is not part of appraisal. Don't you agree? This is where you have the third component of internal failure costs coming in. Defect analysis and bug fixing for internally found defects belongs to internal failure costs. We have included one more example, retesting, under internal failure costs. Can you see why? Retesting is not a planned testing effort. It is caused by defects found, so any testing done to verify defect fixes is considered as a failure cost. Hope you get the point. Finally, external failure costs are similar to internal failure costs, except that these costs are due to non-conformances found by customer post-shipment. When we look at external failure costs, there are a number of other non-obvious costs that come in. Costs due to customer dissatisfaction and loss of business due to poor quality, and so on. The next slide will give you an idea of many more hidden costs of poor quality. This slide gives you a good idea of what are visible costs of poor quality and what are hidden. Costs due to rejects, warranty support, etc. are easy to estimate and are very visible, while opportunity costs due to lost sales or loss of goodwill are huge and often immeasurable. Please take a moment to go through all hidden costs of poor quality. Now that we have a good understanding of what the various components of costs of quality are, you will already have an idea of a typical distribution of various costs in your project or program, as well as your organization as a whole, based on your current knowledge of how things work. It is fairly obvious that internal and external failures represent the biggest chunk of the cost of quality, often exceeding 65 to 70% of the overall cost of quality. Prevention is often less than 5% of the total cost of quality, and this is one of the reasons why failure costs are very high. Can you relate this to the software development process? Less number of defects due to prevention means so much less effort to fix bugs. Do you agree? However, even if a defect is found, the earlier in the life cycle it is detected and fixed, the less expensive it is. For example, if a defect found in requirements phase costs you $1 to fix, if you found the same defect in the final stages of testing, it could cost you as much as $100 to fix. If the customer found that, it could be almost several times higher. Do you agree? So this is where you need to focus your process improvement efforts, in preventing as well as in early detection and fixing of defects. In a typical organization, cost of quality as a percentage of sales ranges from 15% to 25%. In a software development setup, where COQ is measured as a percentage of the total software development costs, COQ is typically between 35% and 45% of the total costs. It would be good for you to compare your projects as well as your organization's COQ in relation to this. This slide presents a simple picture of where the focus on COQ should be. Optimally, a significant part of the COQ should go towards prevention and appraisal. This will reduce failure costs substantially, contributing to a significant reduction in overall cost of quality. Remember, the savings from a reduced cost of quality directly contributes to the bottom line for your organization. In my own experience, I've seen several organizations have saved millions of dollars by focusing on reducing cost of quality as a strategy.